Hi, Sam here from Roberts Geospatial. Today I want to show you how to do a fire scar analysis with ProRaster Scientific. So I'm going to be looking at a bushfire from Western Australia. It's called the Wooroloo fire. It was just out to the east of Perth in the foothills, and it burnt from the 1st of February through to the 6th of February 2021. So let's bring up ProRaster Scientific. So I've downloaded some Landsat scenes already, so let's browse our scenes. Here's the scene browser, zoom into the area that I'm interested in. And this is the particular tile that we want. So if I double click on it, it does a selection for that tile, for that scene, and it selects all the overlapping scenes in that area. So you can see that they're all path 11282, so they're all what we're looking for. Now I want to weed out the data that I don't want and just compact it down to the data that I do want. I'm looking for surface reflectance, so I've got these bottom of atmosphere tiles. So I sort by product, then click on it, and it selects all the ones that match the one that you selected. So then I can collapse to that. So in our family, you can see we've got some Landsat 7, and then we've got 8 and 9. So I'm going to use 8 and 9. Let's collapse again. So, and then sort by acquisition date. So now you can see that I've got all collection 2, all the same instrument, all surface reflectance, bottom of atmosphere, all Landsat 8 until the final one, which is Landsat 9. Of course, Landsat 9 wasn't in the air in 2021, and it came on stream later. So we've really only got Landsat 8 data to play with. So looking at the acquisition date, the first scene is on the 29th of January 2021. So that's 2 days before the fire started. It was a good scene, not much cloud. 16 days later, we get a revisit. This is on the 14th of February. This is after the fire has already been burnt and been extinguished. But you can see this scene is badly cloud affected, 86%. We probably won't get any useful data from that scene. Then on the 2nd of March, we get a scene still with significant cloud, 19.7%. But turns out the cloud is not over the fireground, so we'll be able to use that scene. Then we have another scene in March, which is good. And then another scene the following year, so we can see what it's like a year later in summer, and then a year and a half later in winter. So I'm going to create a product from these 6 scenes. I'm going to create a sequence. So I'll collect them, select them all, and then right click, and I'm going to go create scene sequence product. I then have to select the product database that I want to place it into, and I've already created one for Wooroloo. So let's go OK. And so let's call this the Wooroloo Fire series. So here in my product editor, you have a preview. There's the scene, and now we can start building our processing sequence. So the first thing you'll want to do is render it. And you've got a few options. I just want to explain them briefly. Firstly, you can display now or you can render now. Display and render both create a new algorithm which gets displayed in the main ProRaster interface. But display just simply uses a lookup table algorithm for the first band or the first field, doesn't do anything clever. Render now is going to render the spectral data. So it'll create an RGB band combination algorithm and is a sort of a higher quality product. So there's those 2 options, and you use them in different kinds. Now, if you go down here, you'll also see render algorithm in this section here. And that does the same as render now. It's going to create an algorithm, but it's actually going to save it with the product. And it goes into the product tree. So the advantage of that is that you don't have to save it yourself. It's already been saved. You can then go and modify it and save it. But you don't have to worry about where that rendering algorithm is stored. It's stored with the product. It's got automatic file naming. and you don't have to worry about finding it ever again. You just go back to the product editor and you'll find it via that mechanism. So that's quite convenient. So I'm going to create a render algorithm in the product itself. So it comes up with this little dialog. Choose your spectral target. By default, it'll choose the most highly processed spectral target. So it's gone for bottom of atmosphere reflectance. Then I'll choose my band combination. In this case, we're looking for Fire Scar, and it chooses the appropriate bands depending on what your data is. So if it's Sentinel or Landsat or whatever it is, it will choose these bands appropriately. We don't have pan sharpening as an option here because we don't have a panchromatic band with level 2 data from Landsat, and we won't do any masking. So hit OK, and sorry, this is a two-step process. In this case, I then have to say open in ProRaster, and then it will open. So you can see in our product tree, we've now got a rendering algorithm. This is a Fire Scar, and I'll just close that, and here's our algorithm. So let's take a bit of a look at it, just to show you how to edit these things. Go to the red component. From the red component, you can change settings in the blue and the green components, and also pan component if you're using it all at the same time. And the first thing you might want to do is select the appropriate time range. So at the moment it's going from the beginning right to the end, so you're going to want to choose a particular time. So we'll look at the first scene in January, just before the fire. The fire is going to be in here, and you can see that there's no evidence of it. Now I can drop these down just with the arrow key and skip through the events. So here's the next event. Remember, that was after the fire but very cloudy and we can't see anything. Then on March the 2nd, we also a cloudy scene, but here's the fire ground and you can see that it's not affected by fire. So that's looking good. Go to the next scene. There we have the fire ground again visible. Now we go a year later and it's really starting to fade out. And then in winter, a year and a half later, there's the evidence for the fire is really starting to disappear. So let's go back to March the 2nd. So this is just after the fire. Now, I'd like to kind of punch this up a bit, this data transform, so that we can see this fire ground a little bit better. So go to the color page. And what I should point out, when I was changing that tire range, there's this little tick mark here. It says propagate time changes to all components in the layer. So that's why the red and the green and blue were all updating at the same time just by changing the red. If you go to the color page, there's another little tick and it says propagate changes to other color components. And so when I change this data transform in the red, it's also going to change it in the blue and the green, and that's usually what you want. So we've got a sigmoid lightning transform 25%, clipping from between 0 and 0.5. So that's the standard data transform that ProRaster Scientific will set up for you. We're using reflectance, values are between 0 and 1, so these clipping ranges are appropriate. So I just want to improve the contrast a little bit, and you can do that by just shifting the bottom clip up. You see that contrast just improved a bit, and you might fiddle here with the top, see if that makes any difference. And you can, so we've gone to that clipping there range 0.05, 0.4. You can see it's same in green and same in blue. It's all been mirrored. But it's a little bit green, so I'll go to the green band, and you can see that there's no tick box here. So when I change this green band, it's only going to change green. I just want to get rid of the green a little bit, make it a little bit more punchy. Bring that up, and that looks really good. So now we're really picking out the boundary of the fire scar. You can see that there's some areas within the boundary that haven't burnt, though mostly it's been burnt. But I like that transform. That's really highlighted that fire scar against the background very successfully. So remember, we're looking at an algorithm that's being saved somewhere. You can see that up here in the title bar. It's modified and it's going into this render b.mrd. So let's save it and come back out here. So our next step is to compute some spectral indexes for the Fire Scar and see which ones characterize the Fire Scar best. Okay, so let's compute an index. So go up to the scene sequence and right-click on it and select Index. So down here you see a list of all the spectral indexes that can be computed. So we're interested in the fire index. So let's click those all on. Now if you select them one by one, you can see down the bottom here the name of the index and the formula that will be used to compute that index. Now because we're working with virtual rasters, nothing will be computed straight away. It's only computed on demand. So we can choose all of these indices and see what they look like, and then later choose which one we think is going to be best for analysis. So let's just hit OK. So we've got a new spectral index object. So let's right click on that and hit Display Now. So we've just got a lookup table color algorithm. So go to the color band. We need to look at that event, the March the 2nd. That's the thing that we're interested in. And you can see that all of the indices that we computed are listed here as a band. So if I go through them, here's our Fire Scar. I'll just zoom in on it a bit so we can see. So from AFRI, it's not really particularly visible. BAI is really picking it out nicely. MIR BI, not so much. MBR is quite good. You can see it's reversed. MBR2 also reversed, but again, not so clear. NBR SWIR, NBR T1. For my money, I think the BAI index really picks this Fire Scar out best. But you'll find it depends on the country that you're looking at. If it's in forest or if it's in sort of desert country, different indexes perform better or worse in different environments. But I think BAI is the one that we want. So let's get rid of that again. Come back into our spectral index. And now I'm not going to choose all. I'm just going to choose that one that we want. So we've now got our burnt area index. Let's go back to rendering it. So I'm going to right click. Now I've got a display algorithm, not render algorithm, because it's no longer spectral data. Even though it's an index, it's not. It doesn't have spectral data in it anymore. So create display algorithm. Open it in ProRaster. So let's come in and get this looking right. Go to the event that we're interested in. Come into the color page. I don't want to use this pseudo color. We could use something like brown green, for example. And we might want to reverse that color table because we want brown for burnt and green for unburnt. Linear transform, perhaps with some clip. Okay, so that's not looking too bad. But we're going to want to clip out all of this data around the outside because when we do our analysis, we're only interested in what's in this area. So let's take a little bit of a closer look. So turn on the cell value tool. And here we're going from unburnt into burnt. And it does depend a bit on our clipping, but for my money, the transition between unburnt and burnt is somewhere around the value 40, and then it goes up into several hundred up here in the burnt values and below 40 in these areas that are unburnt. So if we come back, so I'm just going to save that. Here's our display. So now I'm going to start clipping things out. So I'll go into the spectral index again. I'm going to add a new operation below that. So I'm going to add a calculator operation. And the input data is BAI coming from our spectral index. And the code we use for that input data is going to be AOO. So now I'm going to clip it just with a clip command. and I'm going to clip the input, which is A00, from 40 to, say, 400. Hit OK. So there's our calculator operation. We can see preview. Let's just display that now. Again, go into our date of interest. So now, here's our fire scar, but you can see around it, a lot of it's now being clipped out. So that's an improvement. In order to get rid of everything else, we're going to need a polygon. Now, I've created a rough polygon around this fire scar, so let's now use that. So let's clip by polygon. Choose the Wooroloo buffer polygon. Hit OK. Let's display this now. Come into here, choose March the 2nd. Now we have something that's focused right in on that fire scar, and we can begin to do analysis in detail of the data within that fire scar. So let's just recap. So in our processing sequence, the first thing we did was we took 6 scenes, all the same scene, and in a sequence, in a time sequence, and we put them together into one raster dataset. Then from that raster dataset, we computed the burnt area index, and that gets computed for each event in that time sequence. Then we use the calculator to clip the data to this range, 40 to 100, to clip out the data that we considered to be unburnt, just leaving the data that is considered to be burnt. And then we clipped that data to a polygon, which I made externally in a GIS application, and that took out everything else around the fire scar and has focused us now down to what we're interested in. So, in summary, we have a data set for burnt area index with 6 events, and we can now compute some statistics for this. So let's hit statistics, process all our fields and bands, choose our resolution level, 0, which is the base resolution, that's usually what you want to choose. Compute statistics for each event. Yes, we have 6 events, we want statistics for each individual event. Hit OK. So it comes up with this little progress bar, and now we have statistics sitting in our product. So here's the summary page. It tells us the number of valid samples within, and that's the number of cells inside this polygon that are valid. And you can see that we have a list here. We can choose our events. So this is before the fire. We can just click between them like this. This is February the 14th was that very cloudy scene, so now we have very few valid samples. After the fire, we have a large number of valid samples, remembering that the valid samples are the burnt samples, because we've weeded out everything else. So these are the ones that are burnt. Next event, it's gone down a little bit. Next event a year later, this was, you can see that it's dropped substantially, and then during winter, again, it's down. So there's our sample counts. We can, we've got our other statistics here, summary statistics, the minimum value, the mean, the maximum, standard deviation, and so forth. So let's come back up to January the 29th. So our mean value there is 50. We then go to March the 2nd, where we have good data after the burn, and now our mean value is 156. So that's reflecting the severity of that burn. Down here you can also see distribution statistics. These are derived from the histogram, so you've got your lower quartile, upper quartile, interquartile range. Useful numbers again, the median and the mode. On the spatial page, it tells you the cell size. So our cells are 30 by 30. And then instead of telling you the number of valid samples, it tells you the area of the valid samples. So this is in meters squared. Then it has these spatial statistics. These are statistics from, that reflect how the data changes from one cell to the next. It's something that you'll only use rarely, and just don't get confused about those statistics sitting there. They're rarely used. And then down here you can have a report, so you can actually investigate the data. So if we look at, say, 60, a value of 60 and above, so it tells you that 90% of that data is equal to or higher than the value of 60, corresponding to 109,612 cells, or an area of all of this. So, and looking in here at our area, this is going to be 108 square kilometres of burnt bush. And then the final page, we have our histogram. So if we come back to, say, January before, so bearing in mind that our burnt numbers are going to be up here. So prior to the fire, our histogram is falls away very rapidly. We don't have any burn. And then after the burn, you can see that it's really filled out. And these numbers in here all represent our burnt pixels. And by the time we get to a year and a half later, you can see that it's come back substantially. Not as far back as it was prior to the fire. There's still evidence of the burn, but it's dropped away quite a bit. So the way I might use this data, for example, I go to the event before the fire. There are 28,157 cells that are indicating that they're burnt. Of course, they're not really burnt. They're just indicating by that index that they're burnt. But then after the fire, that jumps to 120,481. So if I was to bring up, say, a calculator, take that number, subtract that number, gives me the total number of cells that have transitioned from being unburnt to burnt, times that by the cell size, gives me that area, divided by, say, 10,000, gives me 8,309 hectares burnt in that fire. So just finally, I'll show you an algorithm that I prepared earlier. Go into my product. Got an algorithm here for fire severity. So in this algorithm, I've got OpenStreetMaps draped on terrain with burn severity on top, using opacity modulation, so it's per pixel opacity modulation, so I can see through the areas that are not so burnt to the areas underneath, or to the OpenStreetMaps underneath, and then in the areas where we have more severe burns, it will be more opaque. So if we zoom in, you can see what I'm talking about. The fire started around here, burnt through this paddocks and open land, not very severe burn, but as you come into the areas where there's more forest, the burn starts to be more severe. I mean, you can see a patch here, which is all treed, and we've got some severe burning there. And as you progress along the fire ground, you go through various areas of forest and get much more severe burn and so forth. And so that gives you a way to visualize in the context of the topography the effects of the fire. So that's ProRaster Scientific taking a look at the Wooroloo fire from Western Australia 2021. Thanks for watching.